Okay, so first, all B batch student, write down your enrollment number in chat box. All B batch student, okay, B batch only. Write down your enrollment number. Okay, once all B batch student have write down and your enrollment number, now all C batch student write down your enrollment number in chat box. C batch student, those who are online, write down your enrollment number in chat box. Okay, so I think in B and C batch, last time we have discussed up to example number 13. Yeah, up to 12 we have done, and now this ejective normal form, DNF and CNF. I think these things also we have already discussed, DNF and CNF. Ejective normal form and conjunctive normal form. So the sum of elementary product and product of elementary sum, and we have applied the logical argument on this by using equivalent statements. So those equivalent statements which we have already discussed uh, for like mm, this is A complement and B complement if you have given, then how to write this, like, okay, so all these things which we have, I think equivalent statement, three equivalent statement generally we use to we have to convert, see this statement, whatever statement here we have to given, so by using we have to convert into a sum of elementary product, or so for a dejective normal form, sum of elementary product we have to convert into a sum of elementary product, and sum it means or, okay, sum it means for uh, dejectives which we call it or. So for some which we have used for or, and a product which we have used for and, okay, so connectives and here connectives or, for that we have used word sum, and elementary product which I have already given the example, like suppose P and Q which are statement, then P and Q which is your elementary product, or P and not Q which is also your elementary product, okay. If P, Q and R statement, then P and Q and R, which is elementary product, P and Q and not R, which is also an elementary product, P and not Q and not R, which is also an elementary product. So which are connected by AND operator. Okay, so this is, we call it elementary product. So whatever statement here you have given, you have to convert into as a sum of elementary product, sum of elementary products. And so for that you have to use here, you have to use the equivalence statement. Okay, equivalence statements and De Morgan's laws. Okay, so and we have already discussed the how to convert any statement into digit normal form. So procedure we have already discussed in class. Okay, so I suggest first of all everyone to try yourself and find out the dijective normal form for this given A, B, C, D, E. Okay, then later we will going to be discussed, but first try yourself and find out dijective normal form. Okay. So I give you the time, 10 minutes to complete this. I think more than enough. So you must be know about first of all logical equivalence statement. Okay, then you can convert this bijective normal form. Now logical equivalence statement like P implies Q. P implies Q, which is logically equivalent to not P or Q. Not P or Q. Okay. And for if and only like P if and only Q, if P if and only Q, then which is logically equivalent to P and Q or not P and not Q. Okay. So I can show you here like this logical equivalence statement for this P implies Q. Which I can say that which is logically equivalent to uh, not P or Q. And for any P, if and only Q, which is logically equivalent to P and Q for not P and not Q. So this P if and only Q, which I have convert, like I can say that which is the nothing but the sum of elementary product. Sum of elementary product. I have write this P if and only Q, then which is I have write in dijective normal form here. I can say that dijective normal form as this O represents sum, and this is elementary product. Okay, P and Q and not P and not Q, which is elementary product. I can say that which is a sum of elementary product. So I have convert like if P and Q you have two statement and which is related by if and only if, then this is the bijective normal form for P and Q. Now instead of P and Q, it might be any statement. Like so here in example you compare like this this is your P, this whole is your P and this is your Q. Okay, so in this way also you can compare. But so you not only this logical equivalence, you also required some distributive property also. Okay, you require also Demon law to convert in this dejective normal form. Sometimes you require all these things. Okay, and statement P is also logical equivalent to not of not P. Okay, not of not P is nothing but P, negations of negations against statement itself. So first step to convert any statement you have given into a dejective normal form, you have to remove this implies and double implies. Okay, you have to remove this implies and double implies, and by using equivalence expressions. Okay, and which contain the connectives like and, or, and negations. So by using this, we have to convert into. So you have to remove this uh, implies and double implies. Okay, by writing logical equivalent statement and which contain and, or, and negation. Now then second thing you have to do. So if you have a negations before the sum or product of any, like you have negations of P and Q, then you can apply the De Morgan law. As you know that negation of P and Q, which is nothing but negation P or negation Q. Okay. And then you have to apply the distributive law until you get the sum of elementary product. Okay, until the sum of elementary products. So in this way, you have to find out the sum of elementary product here. So first step in example number 13, first first one A is here negations of P implies Q and R. Okay, so here we have P implies Q and R. So and we have a logical statement for any P implies Q is not P or Q. So here I can write not P, and then or. I get connectives here, or and or Q. We have Q. So Q it means here we have capital Q and R. Okay, capital Q and R. So this is instead of Q we have this. Okay, I get this. Now we have this negations outside this, not P or Q and R. Okay, so if we apply this negations outside the we have this not P or Q and R. If we apply this negations, what I get? Capital P according to De Morgan law. Now capital P and instead of now or I get N, and then negations. So which I write in bracket, negations Q and R. Okay, and okay, so this is dejective normal form, which is nothing but the sum of elementary product. Okay, sum of elementary product, and here I get uh, so I have to convert into this form. Okay, I have to convert into the sum of elementary product. So sequentially I have to use now. I have first remove this implication sign, then I have applied the Morgan law. Now by using distributions, okay, distributive property, I have to convert into a sum convert into a dejective normal form. It means is a sum of elementary product. Okay, so first of all, again here we can apply the De Morgan law. So if I apply the De Morgan law, what I get here? Not Q or yeah. So this is P N. I have N, then in bracket negation Q 4 or negation R. Okay, now I can apply the distributive property. So according to distributive property, I can write this P and not Q for P and not R. Okay, so see, you can see that this P and not Q, which is an elementary product, P and not R, which is also elementary product, and here, so which is a sum of elementary product. I can say that this is a dejective normal form. Clear, everyone? Is it clear for everyone? Okay. So the now next one, try yourself. This is B. Okay. Negations of P or Q if and only P and Q. So my first task is to remove this if and only by using logical equivalent statement. And P if and only Q, it means P and Q or not P and not Q. Now as P, I have negations of P or Q, which is my P, and this is my Q. Okay, so according to this, first P and Q. So this P and Q, so which I can write as, okay, so I copy this for N Q. Now I have to use N, and Q it means P and Q, capital P and Q. And then 4. Now not P, not P it means P or Q. Okay, only this, not negations of negations, again statement itself. So I get this. My not P and not Q. So not Q. Now negations of P and Q. Okay. Now you have to convert into a bijective normal form. So first you can apply here De Morgan law and then distributive property. So which I can write as this, instead of this negations, if I remove this negations, if I apply De Morgan law, what I get, negation P and the negation Q. So here I get and. Negation Q and P and Q. Okay. Now here we have or. Okay, this is okay. Now here if I apply the De Morgan law, what I get is negations P or negations Q. Again, it's equivalent to. Okay, so we have and here, so not P and P. So which is true? T. I get T. Not P and P. Okay. So for not P and P, 0 false. I get false. Okay. And for not Q and Q again false. So false and false. False. Okay. So for all these statements I get F. Is it clear? Now F or. And here we have this is okay. So now here we can apply the distributive property. So for that, first I write this bracket, and first I distributed this first bracket, okay, with this not P or not Q. So P and P and not P, not Q. And then we have or. Okay, we have or. Okay, so these four statements I also have right to in the bracket. Okay, now I have distributed. So here I get or, and then or we have to end again this. Okay, so this is previous one as it is, but uh, control V, but instead of, okay, so again I need a bracket, control P, but instead of P now I have Q. Okay, okay, so now again this F and F4, we have F4. So in bracket now again we can apply this, see, for this distributive property we have P and not P or not Q. So here I can apply distributive property, okay, with this bracket. So first I write the bracket, now in which I have bracket, and for that if I apply distributive property I can write P and not P, P and not P. Then I get or, and this is P and not Q. Okay, and now this I have to write in bracket, all these things which I have to write in bracket again. So what I do, now or, we have or, and again here P, Q and not P or not Q. So I get in bracket Q and not P, Q and not P, okay, Q and not P, or Q and not Q. Okay, so now P and not P, it means P and not P, it means F false. Okay, so I get F. Similar my Q and not Q, F. Okay, so what I get is logically equivalent to, now F for any statement, F for any statement itself. So I can remove this F for. Okay, so I get only this bracket. Now again this, if I write all this in, this is one in one bracket, then F, I get F 4, F4, F4 Pn not Q. Okay, F4 Pn not Q. Okay, and or I have this in bracket, if I write in this bracket, okay, now Q and not P, Q and not P, for F, okay, again F, Q and not Q, it means F, and I have already told you that F or any statement itself, so we can remove this F. So what I get, this P and not Q, or Q and not P. So this is nothing but the sum of elementary product. Sum of elementary product. Okay. So this is a bijective normal form. Clear? So is it clear for everyone? Is it clear? Okay.
Yes,
Brajesh
sir.
Kumar.
Yes, sir.
Okay. Chandra. Yeah. Abhiraj. What about
Yes,
others?
sir.
Okay. Write down in chat box if you have. Okay. Jai, Amit, Saista. Okay. Karthik. Yes. Okay. Good. So I think now everyone has cleared this dejective normal form. Okay, so now next one you can try by yourself. This next one you can try by yourself. Next one, try yourself. And next one is C here. Okay, C. see here negation of negation, so statement itself. Okay, I get the statement itself. So here statement is P if and only if Q and R. And now see P if and only if Q as logical equivalent statement we have P if and only if Q is P and Q or not P and not Q. So here my P is capital P and small q is capital Q and R. So P and Q, P and Q. Okay, so what I have to require here, bracket P and Q, it means this Q and R. Or not P. And not P and not logical equivalent we have not P and not Q. So not P and not Q, it means Q and R. Of De Morgan law. Instead of this, what I get, not Q or not R. Now here we can apply the distributive property. So which I get not P and not Q. Or not P and not R. So this is the elementary sum of product. Now here also we have or, and this is the elementary product. Okay, I can write this P and Q and R, P and Q and R. So this is the elementary product. Okay, instead of this, I can write this. Okay, like this is P and Q and R. So this is also elementary product. And sum, again this is elementary product, sum. But now see, here we have sum of this. Okay, so we have to distribute this over this. Okay, in bracket we have this. So if we apply or, yeah, we get same. Okay, so we can remove this bracket. Now we can remove this bracket. and we get same as it is. Yes, we have. So this is the sum of elementary product, so bijective normal form. Clear? The next one, try yourself. E. So similar manner, conjunctive normal form, it means product of elementary sum. Product of elementary sum. And you have to apply the same procedure. You have to apply the same procedure, okay, for conjunctive normal form. E नहीं हो रहा. Okay, let us. D is done. D. E में नहीं मिल रहा, ऐसा बोल रहे हैं आप. नहीं हो पा रहा. Then P and not Q and not R. Okay, we have given this. In first bracket, we can apply De Morgan law. Okay, so what I get, P and not Q or not R. Okay, so P and in bracket not Q or not R, and we have or, again we have or. Now P implies Q. P implies Q, it means not P or Q. I think P implies Q, it means not P or Q. Okay, so not P or Q. Now in first one, we can apply the distributive property. So what I get, P and Q or and here we have or and or. Okay, so this P or Q, okay, which we have to convert into N. Or now this. Okay, so this or we can distribute it over this end. See this or and this or. So I can remove this bracket, this one. This is nothing but the, here I can say that okay, uh, this O. Uh, so if I distribute with this two, okay, so this is also a O. Three are okay equivalents. So what I do here is equal to, right, first one is P and not Q, control C, and we now or, which is or. Okay, now I can distribute this not P or Q with this P and not R. Okay, so what I can say here is P and not R or not P. Okay. And P and not R or Q. or not P. Okay. Again or now P and not R Q. Okay. So what I do, I write is same as this previous one, but instead of not I just have to write Q. Okay. Now okay, so how we interpret this? This is first one is equivalent, and for B. Now we have to look at this table. This is Pn not R or not P. Okay, so now again we can distribute this Pn not P or not R and not P. Okay, bracket is Pn. Okay, so I can write P and not P. Pn not P. Or P not R and not R or not P. Not R. Okay, P and not P or sorry, not we are distributive over or. Okay, so what we can say here, P and not P, uh, not R and not P. Okay, not R and not P. Now or now here we have P and Q. Okay, P and Q or not R and Q. Okay, not R and Q. Okay. So P and not P it means F. Okay. Okay, now F or any statement. So statement itself. So first of all, I can write here. Okay, this one is logically equivalent. This is as it is. Okay, now for this one, right now. Okay, so this is whole bracket right now. Okay, I take whole bracket. I will make change it here. First one, this P and not P, which I can write as F. Okay, but now and this not okay F and this one P and Q or not R and Q. Okay, fine. Now see, f for any statement, f for any statement itself, f for any statement, okay, f for p is equal to p. So what I get here, this one is as it is. Okay, okay. Now here, f for this, so this statement itself. So okay, I can write only this one, not pn, not rn, rn, not p, or this p and q or qn. So now I can remove all this bracket, and this is the sum of elementary product. Yeah. Okay, sum of elementary product. I can remove now all this bracket. So I can write as this is nothing but logically equivalent to p and not q, or okay, so yeah, we have this. Okay, this is whole bracket, or okay, so or, so I yeah, same as I can write this as okay, and or. So I think this is a sum of elementary product. Okay. Now, is it possible to give more further simplification? I think need not to be given. This we already get this DNF, rejective normal form. Okay. So is it clear for everyone? First of all, is it clear for everyone?
Yes, sir. Hello, sir.
Yeah. Any doubt?
Hello. Yes,
हाँ
sir.
अमित कुमार, या बोलिए.
सर स्टेप 5 में सर समझ में नहीं आया.
हाँ स्टेप 5 ओके. ये फर्स्ट, second, third, fourth, and fifth. So P and not P. Here I have changed only P and not P is equal to F.
नो सर.
Okay, P and
इसके ऊपर.
yeah, ये step समझ में नहीं आ रहा.
Yes, sir.
Okay, so what we have to here, we have see, we have P and not R and not. Okay, so this is we have P and not R or not P. Okay, so we have distributed and over or. So this is P and not P, or not R and not P. Okay, so this n is distributive over or. Okay, like suppose we have a plus b into c, then how we write it? A into c plus b into c. Is it clear? So similar manner here, p and not r or not p. So what I have write? P and not p or not r and not p. Now clear, Amit?
Yes, sir.
Or still you have doubt?
No.
ओके, इसको मैं आसान तरीके से अगर दिखाना चाहता हूँ तो इस तरह से मैं कह सकता हूँ कि अगर आप मान लो ये एंड है वो मल्टीप्लिकेशन से है, ओके, और है वो सम है. ओके, सो मैं यहाँ पे लिखता हूँ फर्स्ट एन लिखता हूँ. चलिए ए इंटू बी, ओके, n my and okay now a इंटू माइनस है क्योंकि नेगेशंस है तो नेगेशंस को मैं माइनस की तरह देखता हूँ अगर यहाँ देखना चाहूँ तो माइनस ए और या तो मल्टीप्लिकेशंस के तौर पे 1/a देख सकते हैं ओके पर ऑल्सो मैं ए डैश चलो लेते लेता हूँ ए डैश ओके ए एंड नॉट बी मीन्स ए एंड ए डैश एंड दिस और को मैं सम की तरह लिखता हूँ सम and which is my not R and not P. Okay, so I call it in bracket B dash and not P. Not P it means A dash. Okay, so which is equal to I can write this. Uh, okay, so in previous I have write. Okay, so this P and not R. P and not R. So I can write this is as uh, in bracket A plus B dash into okay what we have P and not R P and not R so A and B okay so I have make a mistake this is A and B and B dash and A dash and O fine and previously we have P and not R P and not R P and so A and B dash plus I have A dash to no this is not like that I'm not explaining this manner. Now this is a distributive property like this is P and so okay so we have negations because of that I think you are confused and also confusing me this one is P I write as any statement like this P and 2 and then we have or okay or negations of P so or if I write R okay so how we can write this first of all okay if I want to apply the distributive property then I can write this is nothing but P or R P or R and Q or R is it clear the same thing I have done in this step fourth step Amit is it clear am I audible
Yes, sir.
so is it clear first of all or still you have doubt
सर ऐसे तो स्टेप नहीं है सर
hmm?
सर क्लियर नहीं हुआ
मतलब ये distributive property we have used distributive property so and over R you can check this by truth table okay I think by truth table you can find out this both are equivalent okay so let us try this first is it true okay if we want to check this corrections of this then okay what I do I draw a truth table okay for that we have a three statement P Q and R okay so for that we need like this is my P Q, and R. Okay. So three statements. So first T, 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 F, 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 and F. Now for Q, I can write T, T, F, F, T, T, F, F. And for R, I can write T, F, T, F, T, F, T, F. Now, what we have, we want to check this P and Q. First, I write P and Q. Okay, P and Q. Okay, so for this P and Q, uh, okay, so true and true, I get true. Again, true and false. Again, false, false and true, false, false and true, false, false and false, false, and again false. Okay, and second thing I have to write P and Q, and then or R, P and Q or R. Okay, so I write in bracket P and Q or R. Okay, so now I have column of R and P and Q, column of P. So here T or T, true, uh, true, T and F, true. Is it okay? F and or F, F, then true, then F, then true, and then is it clear for everyone? समझ में आ रहा है? Now I have to add okay. So we have find out RHS. Okay, now LHS P or R. P or R. First I write P or R. Now P or R. So T or T I get true and true and false, true and again true, again true, and F or T I get T, F or F I get F, F or T I get T, and F or F I get false. Okay, now again I need one more column. Again I need one more column. So P or R we have find out. Now we want to find out Q or R. Q or R. Okay, so Q or R. So first I get T and T and T and F. Okay, and then T. Okay, then T and
Sir,
yes, and then yeah, P F. Okay, is it correct? At any point you have doubt in this? Okay, now P or R and Q or R. Okay, so this is P or R and Q or R. Okay. So now we have these two columns and we want to apply AND. True, 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 false, true, false, true,
Sir,
false. Now see, we have to compare this one. This
sir,
TTT. Yes, 1 second. Okay. So see, we can see that these both uh, equivalent. Okay. So I think we can write for this P N not R or not Q. So this is a distributive property. Okay. Amit Kumar, is it clear? Or you have any doubt?
सर वहाँ पे पी और नेगेशन पी एंड नेगेशन आर
P and negation P or negations R and negation P.
सर वहाँ पे और ना होगा पी और
हाँ यहाँ
नेगेशन
पे
पी यस और बीच में नेगेशन एंड होगा
see this is in bracket P and not R which is in one bracket and then or not P. Okay, so this or which is distributive over this bracket. So this P uh, okay, this P and I can write in this manner also P or not P and uh, not R or not P. Okay, if I write and then, but I have write this P and not P or not R and not P. So in both way you can distribute over and or over R. Is it clear? Like if I distribute P or not P, P or not P, then and not R or not P. I get this way, not R or not P. Okay, in this way also you can distribute. Is it clear?
Yes, sir.
Okay, so I think this is clear for everyone now. And we have find out bijective normal form. And similar manner, conjective normal form, you can do it by yourself now. I think very. So now in conjective normal form, you have to write the product of elementary sum. Okay, product of elementary sum. A and B done. Okay, so you can find out easily C and F for given statements. So now what about others? As everyone has done this A and B. Okay, assignment example number 14. If those who have completed, reply in chat box. Okay. Okay, Amit Kumar done. What about others? If anyone have doubt, you can ask. Okay. CNF it means product of elementary sum. Product of elementary sum. So you have to convert this statement into a product of elementary sum. So how many of you have completed this example number 14? Reply in chat box. Or if you have any doubt, then you can also ask. Okay. So only A. Amit Kumar say only A. Now what about others? Rajesh, Rinku, Chandan, Bajrang. What you get?
Hello, sir.
हाँ अमित कुमार बोलिए.
Can you explain B, sir?
Hello.
Can you explain B?
B. Okay. So here B we have not P or Q. If and only P or Q. Okay. Not P or Q. And if and only if not P or Q, if and only P and Q. P and Q. Okay, so first of all, this equivalent, if I want to write down, then I call it Q, then P if and only Q is nothing but P and Q or not P and not Q. Okay. So P and Q, this one, so I write in bracket, and this is my P, and then and this one is my Q. Okay, so this is P and Q or not P and not Q. Okay. Now O in bracket, again I get a bracket, not P. Not P means negations of negations I get here, P or Q. P or Q. And negation of P and Q. So product of elementary sum. I required product of elementary sum. Okay, so first we can apply De Morgan law. Okay, so this not P and Q, which you can write as not P or not Q. And here we want to find out the product of elementary sum. Okay, this is not P and not Q. Okay, so all are end. Here we get all are end. Or now again this is P or Q as it is this. And now this negation P or negation Q. So this is the product of elementary sum. Here we have product of elementary sum. Now we require here product. Okay, and first of all, how we can simplify this? So yeah, here we have this is here we have and. So I can write this is not P and not P and P and not Q and Q, as we have all are n. Okay, see this all are n, so I can write this as not P and P and not Q and Q. But now not P and P, it means false. So false and false. Again, not Q and Q is also false. So what I get here? Okay, first, okay, so one more statement I write here. This is false. I can write this as not P and P, and this is not Q and Q. Okay, and this is as it is.
The
Am I audible?
Yes, sir.
Yes, sir.
Okay. So here see, I have completed this example. So at which point we have disconnect? Can anyone say? Okay. So here I have completed example. If you have any doubt, you can ask. Is it clear, Amit? Now? But see, this whole assignment which is in your mid-sem exam, okay, this is unit 2 is whole in your exam portion, and this validations and all these things which we have tautology and truth table and without truth table, validations, argument, and all these things which we have already discussed. So, and this predicate calculus, how to write down this, okay. So all these things which we have discussed here for all, and there exist, and all this logical argument, how to write down this like statement P, Q, and R, and then how to symbolically express it. So how to use this predicate calculus for this following statement. Okay. So this is your part of mid-sem exam. Even we have not done this example in lab, but you have to do by yourself. And if you have any doubt, you can ask. Okay. 15. Okay. This H1 and H2. So validations. Okay, I show you in a PPT, so you get the idea. I show you in PPT. Yeah. So PM. Yeah, validate argument. So, like a finite sequence of statements a1, a2, an, n minus 1, and an is called argument, and n is called conclusion. Okay, so first a1, a2, a3, n minus 1, n is called a logical validate statements if this a1, n, a2, and a3, and an minus 1 implies an is a tautology. Okay, so here this H1 and H2 implies C. If you get which is tautology, then you can say that this argument is valid. Okay, H1 and H2 implies C, which is tautology, then you can say that this is a valid argument. Clear? Okay, I think time is over. So remaining example you have to try by yourself. Okay. So we stop here. Okay, so now you can leave. Okay.